Let's discuss the slope-intercept form of a line. The slope-intercept form of a line means it's a way to express the equation of a line in terms of its slope and its intercept. Okay, now that means we are going to need two information from a line. So given the line, we will be needing the information regarding its slope, which will be denoted by m, and we'll also need the information regarding its y-intercept. So we're going to denote the y-intercept by the letter C. Sometimes it's also represented by the letter A in some textbooks. For this particular case, I'll be using C. Now, the y-intercept means that it's distance of that particular point in which the line intersects with the y-axis from the origin. To understand this problem, let us consider a line segment. So here we have a line, and we're going to consider the slope of this particular line to be m, and for simplicity purpose we're considering a positive slope because the angle that the line makes with the positive direction of x-axis, which is theta, so theta is an acute angle. Okay, so it's also going to work for theta if its theta is an obtuse angle, but to understand this problem we're going to consider a positive slope. Now this particular line crosses the y-axis at a particular point, so let's call that point as A, with the coordinates 0, c. That means the y-intercept of the line, that's going to be positive c. Fine. Now we are going to consider a point which lies on this line, and let us call this point as P with the coordinates x, y. Now that we have 2 points, point that lies on the line, one is point P having coordinates x, y, and the other point A with coordinates 0, c. We can define the slope of that particular line. So the slope will be equals to, we'll have to take the ratio. In the numerator, we take the difference of the y coordinate, so that's y minus c, divided by the difference of the x coordinate, so that's x minus 0, which gives us m equals to y minus c divided by x. Cross multiplying gives mx equals to y minus c, or simply put, if we can have y equals to mx plus c. So this is referred to as the slope-intercept form of a line. So that means given any line, if we know the value of its slope and the value of the y-intercept, then we can easily define the equation of that particular line. Okay, in order to understand this particular idea, let's work with few numerical problems. So here we have our first problem. Determine the equation of a line that has a slope of -1 and cutting off an intercept of 4 units on the negative direction of the y-axis. Okay, so let's try to understand it graphically first. Now it's given here that the slope of the line m, so this is given to us, we're going to denote the slope by m, so that's -1. And also it has an intercept of 4 units on the negative direction of y-axis, meaning the line is going to cut the y-axis at y equals to -4, which means that this particular value is, which is -4, this is going to be the y-intercept of that particular line. Okay, now since it has the line has a negative slope, meaning an obtuse angle, so that means our line is going to given by as shown in the diagram here. So this particular angle, which is the angle it makes with the positive direction of x-axis, that's an obtuse angle, that's why we have a negative slope. Okay, now we can easily find out the equation of this line because all we need is the y-intercept, which is -4. Now we know that the equation of a line that's given by y equals to mx plus c or mx plus a. Here we have y equals to, so m will be replaced with -1, x value, that's simply x, plus the y-intercept, that's -4. So we have y equals to -x minus 4. Or if you want to rewrite this will be simply x plus y plus 4 equals to 0. That's going to be the equation of the line. However, it's better if we leave it in this particular fashion. So this tells us that the given line is in the equation of the line is given in the slope-intercept form. Let's go to the next problem. Now, problem number 2. Determine the equation of a straight line that cuts off an intercept of 5 units on the negative direction of y-axis. So intercept of 5 units on the negative direction means the line has to pass through the point y equals to -5. So here we have the y-intercept on the negative y-axis, and also the line is going to form an 120 degree with the positive x-axis. So let's consider a line which passes through the point y equals to -5, such that this particular line makes an angle 120 degree with the positive direction of x-axis. Our goal will be to determine the equation of the line. So here we know that we need y equals to mx plus c. The c value that's known, where c is given, that equals to -5, but we don't know the value of m. But what we are given here, that the angle that the line makes with the positive direction of x-axis. So if we take the tangent of that particular angle, then we are going to get the slope of the line. Oh, that's fine. So let's compute the value of tangent of 120 degree. The 120, we're going to rewrite it as 180 degree minus 60 degrees. So that will be tangent of 2 times 90 degrees minus 60 degrees. Now 2 times 90 means we have an even multiple of 90 degrees, so tangent is going to be tangent function, but the new angle is going to be 60 degree. Now 2 times 90, here the number 2 also tells us that we are in the second quadrant. Now second quadrant means the tangent function is going to be negative, so that means our slope is going to be negative times this the value of tangent 60 degree, which is square root of 3. So we're getting a negative slope here, which is evident because the angle is an obtuse angle. So now we can substitute all this value back into our standard equation, or you can say the equation of the slope-intercept form, to get y equals to -3 times x plus the y-intercept, which is -5. So this is going to be the required equation of the straight line. Let's go to the next problem. Problem number 3. Determine the equation of a line equally inclined to the axis and cutting off an intercept -1 on the y-axis. So let's start with the intercept part. It's given here. The line is going to have a y-intercept of -1. That means it's going to pass through the point y equals to -1. Now, the first condition that's given to us is that the line is equally inclined to the axis. Now, before going there, our line could be either have a positive slope or it could have a negative slope. In both the two cases, it has to pass through the point y equals to -1. So let's say the line passes through -1 and has a positive slope. So here we have the line which has an y-intercept of -1 and it is equally inclined to the axis. Equally inclined to the axis, that means the angle that the line makes with the positive direction of x-axis is going to be same as the angle it makes with the positive direction of y-axis. Now that means it's actually bisecting the angle between the x and the y-axis. So we can say that this particular angle is going to be 45 degrees. So our goal will be to obtain the equation of the line which makes an angle 45 degree with the x-axis and passes through the point 0, -1, or we can say it has a y-intercept of -1. There is one more possibility. The line is going to have a negative slope. So this particular line is going to have a negative slope because the angle is going to be an obtuse angle, the angle that it makes with the positive direction of x-axis. However, it's given here that this particular line is also equally inclined to the axis. That means if we consider this particular angle, that this angle is the angle that the line makes with the negative x-axis or the negative direction of x-axis is going to be of the same value that with the angle that it makes with the positive direction of y-axis. So these two angles are going to be equals. Now we know that the angle between the y-axis and the negative x-axis, that's 90 degrees. So this angle is 45 degree. Now if this is 45 degree, what's the value of this particular angle? So that's going to be nothing but 180 minus 45 degrees, which means it's 135 degrees. So that means the yellow line, which makes an angle 45 degree with the positive direction of x-axis and has a y-intercept of -1, we need to find out this equation. And for the blue line, it makes an angle of 135 degrees with the positive direction of x-axis and also has a y-intercept of -1. So we'll get two equations of line actually. So let's start with the first one. So we have m, so let's call m equals to tangent of 45 degrees because we're considering the yellow line here. So m, the slope will be tangent of 45 degrees, which is simply equals to 1, and the y-intercept, that's -1. So that means we get the equation of the line y equals to m times x plus c, or simply put, y will be equals to x minus 1. So this is going to be the equation of the yellow line. Now let's go to the blue line. So the blue line has a slope given by m equals to tangent of 135 degrees. So we'll need to compute the slope first. So this will be equals to tangent of 2 times 90 degree minus 45 degree. So 2 times 90 means we have tangent, and 45 will be the new angle, and in the second quadrant the tangent function is negative, so we have -1, and it makes perfect sense because theta, which is 135 degrees, is an obtuse angle, and because of that we are getting a negative slope. Now here also the c value is -1, which implies that y will be equals to m times x plus c, or simply put, we have y equals to negative x minus 1. So that's going to be the equation of the blue line. So we have two equations. Okay, let's go to the fourth problem. Problem number 4. A straight line makes an angle of the inverse tangent of square root of 2 with the x-axis, and it cuts off an intercept of negative 3 over square root of 2 with the x-axis. So determine the equation of the line. So let us begin. So here we are given the angle that the particular line makes with the x-axis. So that means theta will be equals to tangent inverse of square root of 2. So what we'll do, to find out the slope, we'll take the tangent on both sides. So we get tangent theta will be equals to tangent of the inverse tangent of square root of 2. So that means we have tangent theta equals to square root of 2. So this is going to be the slope of the line, m equals to square root of 2. So that's a positive value. This being a positive value, that means theta is a acute angle. Okay, fine. Now it's given here that the line has an intercept of negative 3 over square root of 2 with the x-axis. It means that it has an x-intercept, but our goal will be is to obtain the y-intercept, not the x-intercept. So let's try to look at the diagram. So here we have the coordinate axis. It's given here that the line has an x-intercept of negative 3 over square root of 2. Negative means it's going to lie on the negative x-axis. So this is the point that corresponds to x equals to negative 3 over square root of 2. So a line has to pass through this particular point, and it is going to be making an acute angle with the positive direction of x-axis. So let's sketch the line. So this is the line whose equation we need to obtain. We do have the slope here, but what we are measuring is the y-intercept. So this is going to be the y-intercept. We don't need the x-intercept. So in order to find out the y-intercept, so let's call this point A. A is the point where the line intersects the y-axis, and is going to have a coordinate 0, c. Fine. Our goal will be to obtain the value of c. Now we know that the slope of the line that's given is square root of 2. So square root of 2, that will be equals to, if we use the definition of slope, because we need 2 points lying on the line to obtain the slope. So that means we have to take a ratio. In the numerator, we'll start by considering the difference of the y coordinate. So if this particular point is passing through the point x equals to negative 3 square root of 2, so that means the coordinate of this point, let this be b. So its x coordinate will be negative 3 over square root of 2, and the y coordinate will be 0. So the difference of the y coordinate, so that's 3, as it's c minus 0, divided by the difference of the x coordinates, so that's 0 minus 3 over square root of 2. Okay, so let's solve this. We're going to get square root of 2 equals to c divided by, so we have negative of negative, so that means this becomes 3 over square root of 2. So square root of 2 will go to the numerator. Or solving for c, we get c equals to positive 3. That means the y-intercept was going to be 3. Makes perfect sense, because the y-intercept is positive, means the line intersects with the positive y-axis. Okay, now that we have the c value as well as the tangent, we can find out the equation of the line. Therefore, we have y equals to m, which is square root of 2 times x, plus the y-intercept value, which is 3. So this is going to be the equation of the line. Let's do one more problem. Problem number 5. We need to determine the equation of a line that cuts off an intercept of 3 on the y-axis. So that means the line is going to pass through the point 0, 3. We're going to name this as point A. And the line is going to be parallel to another line, which is formed by connecting the points 3, negative 2 and 1, 4. So let's try to roughly plot the point 3, negative 2. So we have 3 units on the x-axis and negative 2 on below the x-axis. So this is going to be the point 3, negative 2. And we have another point 1, 4. The 1, 4. This is going to be the location of the point 1, 4. Okay, we're going to name this points at point A, point we have already considered A, B and C. So we're going to join C and B, and that's going to be a straight line. Now our goal will be to determine the equation of a line which is going to pass through the point A, and this line is parallel to line CP. Okay. Now in order to determine the equation of line, let's call the line as line L1. We need the y-intercept. So we already have that value, that's 3 units, and we also need to obtain its slope. But here we are given the line CB and the points C and B are known. So what we can do, we can use that information to obtain the slope of line CB, and since it is parallel to line L1, both of them are going to have equal slope. Okay, so let's begin by first obtaining the slope of the line CB. So that will be equals to the difference of the y coordinate, so that's 4 minus -2, and in the denominator we have the difference of the x coordinate, so 1 minus 3. So 4 minus -2, that's 6, 1 minus 3, that's -2, so that means our slope is going to be -3. Fine. So here, if the slope of CB is -3, then by definition, slope of L1, that's also going to be -3. And now we have all the information that we need. We have the y-intercept, that's +3. So therefore, the equation of the line is going to be y equals to m. So here m is the slope, -3x plus the y-intercept 3. So this is going to be the required equation of the line. So this is how we can use the slope-intercept form to obtain the equation of any given line.